Hey, it's Mr. Lum, and sorry I'm not there today, but we're going to continue on talking about reaction types. And we talked about synthesis, decomposition, single replacement, double replacement, neutralization, and now we're going to finish it off. And the last one we're going to talk about is combustion reactions. So a combustion reaction is when you have a hydrocarbon plus an oxygen, and it'll always make water plus carbon dioxide. So we're going to take a look at a couple different combustion reactions and go from there. So here is a example of a hydrocarbon. It just has carbon plus hydrogen and plus oxygen gas. Again, oxygen is diatomic, that's why we have the two there. And then it produces carbon dioxide and water. It doesn't matter the order in which you write it. And sometimes you can get some small variations. So you can have like a hydrocarbon, hydrogen carbon with an oxygen in there. It's no difference. It still reacts with oxygen and produces CO2 and water. Now sometimes you can get like different things thrown in there. So this one right here has sulfur thrown in there. And this is still a combustion reaction. It's an organic compound plus oxygen gas burns up and produces carbon dioxide and water. Now, the only difference is that it'll produce sulfur dioxide right there. So I wanted to talk a little bit about balancing, and I wanted to put up some a little bit more difficult balancing kind of questions, and we can put the video on pause in a second and see about if you can try balancing these things. So I have C4H, let's go with C4H10 and throw in the oxygen there, plus oxygen gas, and that's going to produce CO2 and water. Okay. So we can try putting the video on pause right now and give you a minute and a half to try to balance this, and then you can unpause the video and see how I do it. Okay, so hopefully you got the right answer, and we can balance this now. So first off, I see that oxygen is represented a ton of times all over the place, so I'm not going to start with balancing with oxygen. Also, I have oxygen is a lone element right here, and so therefore that's another reason why I don't want to start with oxygen. So I'm going to start with either carbon or I'm going to start with hydrogen. So I'm going to start with carbon. So I see carbon is 4 on the reactant side, and so I'm going to place a 4 right there on the product side. So now there are 4 carbons on both sides. For hydrogen, I'm going to place a 5 right there because now I have 10 hydrogens, and on this side right here we have 10 hydrogens. So now hydrogen is balanced. Now this is the tricky part of balancing the oxygens. So I'm going to take a look at the product side, and right here I have 4 times 2, that's 8 oxygens, and then on this side I have 5 oxygens. So 5 plus 8 is 13 oxygens. Okay, now I have this 1 oxygen right here. That's just 1. So if I can make this number 12, well, then it'll be balanced, and that's an easy thing for me to do. So I'm going to place a 6 right there. Okay, so after I'm done all that, I want to double check my answer. I have 4 carbons, 10 hydrogens, 5 times 2 is 10 hydrogens, and then the tricky one is on the reactant side, I got 1 plus 12 is 13, and I got 8 plus 5, which is also 13. Okay, now if you didn't get that one, I'm going to give a slightly harder one, and but it'll be the same principles. Let's go C5 H12 plus oxygen plus O2, and then again that makes just CO2 and water. So again, place the video on pause, and then we can see about balancing it. Okay, hopefully you have it. I'm going to use the exact same principles as last time. I have 5 carbons, so I'm going to place 5 carbons right there. Okay, I have 12 hydrogens, and so therefore I'm going to place a 6 right there, and now I have 12 hydrogens. Now it's time to balance the oxygens. So for right here, I got 5 times 2, I got 10 oxygens, and right here I have 6 times 1, or in other words, I got 6 oxygens. Okay, so in total I got 16 oxygens. So again, I have 1 right here. Okay, so if I can make this number turn into 15, then 1 plus 15 is going to, then that means the oxygen is balanced. So 2 times blank equals 15. That's going to be 7.5. So I'm going to have 7.5 right there. So 7.5 times 2 is 15. And so I have 16 oxygens, everything is balanced. Now, if you're one of those people that are like, I want to make sure that I have all whole numbers, then just multiply everything by 2. So I'm going to do that right now, and I'll write it in green. So this is going to be a 2 right here, and then 7.5 is going to be 15. The 5 is going to turn into a 10, and then the 6 will turn into a 12. But I would accept both answers. Okay, and everything should still be balanced. Okay, moving on. So we'll go over a couple of these things right here, and hopefully you should remember from Science 10 how to balance a lot of these things, and use your notes a lot to figure out how to balance a lot of this stuff. So first off, for this first one, we have a hydrocarbon plus the oxygen making CO2 and water. That is a combustion. Okay. We have 2 smaller things making 1 larger thing. Okay. That's synthesis. A metal plus a compound, and the metal replaces one of the H's and makes MgOH 2, and then it kicks out one of the H's. Since H is diatomic, it's an H2 right there. So this is going to be a single replacement. An ionic compound, lead 2 nitrate and potassium iodide. That's a double replacement. This one's a little bit trickier. This is an acid because it starts with a H. This is a base. It ends with OH. It produces salt. This is not like your conventional salt, but this is an ionic compound, so therefore it's a salt. And water, so this is neutralization. Okay. We have a single compound plus an ionic compound. The metals switch, so now Fe is now with Br, and so this is going to be single replacement. 1 compound, and it breaks into 2. That's going to be decomposition. 2 things combine and make 1. That's going to be synthesis. Okay, now the tougher thing that we're going to have to learn is I only give you half the equation and you have to tell me what does it make. So if we're looking at our notes and we have two small single elements, well, there's nothing else that it could possibly be except for synthesis. So this is going to be a synthesis reaction. And then, so now, like, what are the products? Well, if we look at our periodic table, we're going to notice that aluminum is 3 plus and chlorine is 1 minus. When we swap and drop, it's going to become AlCl3. Okay? And then we can also, I'm not going to balance a whole lot of these just because it's going to be, I think we're pretty decent on balancing. But I have 2 chlorines, I have 3 chlorines, so my quickest option to make sure that those things are balanced is put a 2 right here and a 3 right here. So that means we have now 6 chlorines, 2 times 3 is 6 chlorines on that side. The aluminum is not balanced, so I'm going to balance the aluminum quickly by placing a 2 right there. Okay, I'm not going to balance all of these ones. Instead, I want to focus on what type of products is going to be made. And again, you can put the video on pause right now, and then hopefully you're able to write up the products. Don't worry too much about balancing. I'm more concerned about you knowing what product it is and what kind of reaction it is. Okay, so hopefully you unpause the video and we can talk about some of these things. So again, ionic compound, it's going to be a double replacement reaction. Now, we did look at this one right here, and this one is a base. This KOH is a base, so it might be a neutralization, but this FeCl2 is not an acid, so therefore it's not going to be neutralization. It has to be an acid and a base to be neutralization. So this is going to be double replacement. So this is the tricky one right here, because we have to be able to identify the compound. So this is going to be Fe. If I was to name FeCl2, that's going to be iron 2 chloride. Okay, from what we learned in chapter 4. So this is going to be iron 2 chloride. Now, why I had to name that is because I wanted to make sure that I understood what ion it is, and it's iron 2. It's Fe2 plus. So the metals are going to switch, and so you're going to have Fe is going to combine with OH. Now, since I know that it's Fe2 plus, and if I look on the back of my periodic table, OH or hydroxide is OH minus 1. When they swap and drop, it's going to be FeOH2. And I have to remember to use my brackets like that. Now, if I look on my periodic table, K is plus 1 and Cl is minus 1. Okay, and so swap and drop is just KCl. And then you can balance it yourselves. Hydrocarbon plus oxygen is going to be making, well, that's combustion, and that's going to make carbon dioxide and water. All combustions are going to be making CO2 and water, unless your hydrocarbon has like a sulfur or nitrogen in there, then it'll make like an SO2 or an NO2 in there as well. Okay, next one right here, we have AlSO4 3 and PbNO3 2. Again, the metals are going to be switched. So Pb is now going to go with SO4 and Al is now going to go with NO3. So I'm going to write AlNO3. Again, I look at my periodic table. I notice that Al is 3 plus and NO3 is minus 1. When I swap and drop, it should be AlNO3 3. Okay? If I went too fast on that one, it's because aluminum on my periodic table is 3 plus. nitrate, which is NO3, is 1 minus. So when I swap and drop, that 1 comes down here, and that 3 comes down here. It looks like it says NO33, so I have to make sure to write my brackets in there to say that there's 3 NO3s. Okay, so it's AlNO3, 3. Plus, this is Pb lead 2 nitrate, and so that 2 is the 2 ion for lead. SO4, if I look on the back of my periodic table, has a charge of 2 negative. So Pb is 2 plus, SO4 is 2 negative, so it's just PbSO4. Okay? And this is double replacement. This is very similar to the, I was first going to say, this is one metal, and this is another metal, and so these metals are going to be switching. So it's going to be BAI. Now, if I look up barium, barium is 2 plus on the periodic table, and I is -1, and so when I swap and drop, it's going to be BAI2. Okay, Mg is going to be by itself, and so I write Mg. I do not write Mg2 here. Mg is not diatomic, and so it does not deserve the 2. It's just a single by itself. Anyways, this is a single replacement. One lone element, just replacing one thing inside of a compound, so it's single replacement. Now this is a common thing here. We have calcium hydroxide plus heat, and this is going to be a decomposition. Okay, and this can turn into a couple of different things, but we can kind of say that it's going to be turning into calcium, and then we'll say that it's going to turn into, this is a few different things. So for this one right here, we can say that it's going to turn to calcium plus oxygen plus, say, like hydrogen gas. Okay. Okay. Again, you can put the video on pause, and hopefully that you can try and do these ones right here. And yeah, so here we have H2SO4, which is an acid. This one right here, we have a base. And so what's going to happen is that it's going to produce water and salt. K is +1, SO4 is 2 minus, so it's going to be K2SO4. Okay. Again, if you were balancing, this is a diprotic acid, or in other words, a 2 acid, and this is a 1 base. So if we have 2 acids plus 2 bases, make 2 water, and therefore it's balanced. Okay. Zinc, single lone element plus HCl. This metal is going to replace the thing that acts like a metal, which is hydrogen, and so it's going to be producing ZnCl. Zinc is 2 plus ion, so it'll be ZnCl2 and hydrogen. Okay, don't forget hydrogen is diatomic, so it needs to have that 2 right there. Okay, again, this is single replacement, and I forgot to write that this is neutralization. 2 single elements come together and make KBr. K on the periodic table is +1, Br on the periodic table is -1, so it's just KBr. That's it. Okay, that 2 is there because it's diatomic. This 2 is right there because it's diatomic. So if I want to balance it, I'm going to be placing a 2 right there to balance the Brs. And now the Br is balanced, but the K is now unbalanced. So then I just place a 2 right there. Okay. Again, I'm not super focused on balancing, but if you are, you can, so we can balance them down. Okay. And sorry, and this is two single things coming together, so that's synthesis. Here we have Mg plus iron sulfate. Now the question is, what kind of iron sulfate is this? And since SO4 is 2-, that means Fe has to be 2+. So this is iron 2 sulfate. Okay, so which isn't necessary to answer this question, but magnesium is going to kick out the iron, and so it's going to be Mg. Mg is 2+, SO4 is 2-, so we're just going to make MgSO4, and then it kicks out the iron, and that's right there. So since this is a single element, replacing one of the things in a compound, this is single replacement. Very similar to this one up here. Okay, hopefully that makes sense on how to do this. You should have a worksheet right now to get some practice on predicting the products and also classifying some of these reactions. And yeah, anyways.